Okay, classification of matter. So everything can be classified into in matter, and it can be classified two different ways. And what are those two different ways? Huh? Elements and compounds? No. Mixtures and pure substances. Okay? So we have two different kinds. You're either going to be a mixture or you're going to be a pure substance. And so what we have to do is let's take a look at the pure substance. So if we're going to pure substance, you're going to look and see is it a variable composition or is it the same? So if it is not a variable composition, then it is a pure substance. And then pure substances can be broken down into two things? Elements and compounds. And compounds are made up of one or more types of atoms. Whereas elements are just one type of atom. The other thing we have are mixtures. And mixtures can be broken into what two types? Heterogeneous and homogeneous. So homogeneous, what can we say about homogeneous mixtures? They're what? They are also known as solutions. These are going to be blended and one phase, okay? So that means they're going to have to be soluble within each other. Whereas so what types of heterogeneous or homogeneous mixtures can we identify? Give me a homogeneous mixture. Anyone? What, salt water? Yes? Anything else? Was that Marcus? Huh? Blood is homogeneous. Okay? It is homogeneous up to a point, and then it becomes heterogeneous when it starts to settle out. Okay? And then heterogeneous means it is going to be in layers, okay? Or we're going to have things that are immiscible. Different phases. What kind of layers can we think of? Or what kind of heterogeneous mixtures can we think of? Cake. Okay. Non-food. Any heterogeneous things that are non-food? Lava lamp. Okay. I would not want to eat a lava lamp, so all right. If you have your sand and your iron, that would be heterogeneous, and we could, if the sand or the iron's all at the bottom, iron filings, and we can pull that out. Granite is heterogeneous. What kind of solid homogeneous mixtures can you guys think of? What was that?
I was going to say
alloys. Alloys? Yeah, alloys. Huh? Bronze? Brass. Okay, so those are homogeneous mixtures. Any questions over the types or classifying matter? We're going to talk about particulates. The AP is big on you seeing things in particulates. So here you have an oxygen atom and a hydrogen atom. And when they put them together, you see the water molecule. What else can we see about this water molecule? What else have they done? They have made it what shape? They've made it bent. Okay? So they've put the shape in there. If I ask you to draw sugar, I do not want you to go and do this and say that's a sugar molecule. That is not a sugar molecule. You need to give me the C6H12O6 if we're doing glucose. You need to draw that out as particles. If I tell you to write oxygen or to draw oxygen molecule, do not just give me that, because oxygen is what type of atom? It's diatomic. You need to draw them. So we are going to be drawing lots of particles in here. And you need to get used to drawing them in proportions, where it is balanced out. I might give you a problem with all these balls in there, and you're going to have to go in there and count each ball to make sure that it's balanced. The AP exam is big, big, big on this. Questions? Everybody good? We're not going to draw them right now, but I eventually will be having you draw them. Y'all are going to be happy. Today's lecture is really short. So, okay. Here, again, drawn particles. We have a solid, a liquid, and a gas. You see that the solid is nice and structured. Okay. The water, what happens to the particles when we start into the liquid? The particles get looser. They're not as structured. And then how can we tell that the other one's a gas? It's same amount of area. How can we tell that the other one's a gas?
Particles move freely.
Particles are moving freely. You see that little tail there? That means that they're probably moving really fast. And the particles are further apart. So again, you must be able to look at particles like we will here in a minute and tell me, is it a solid, or is it a solid, a liquid, or a gas? What type of phase it is in. Does anyone have any questions over that? Okay, so here we go. We have A through P, and they are different atomic levels, or at the atomic level. You need to do, we have three categories. First, you have to tell me, is it homogeneous, heterogeneous, or pure? Is it, and then the next category, is it an element, compound, or both? And the next one is a solid, liquid, gas, or combo. So let's look at the first one together. Category 1, is it homogeneous, heterogeneous, or pure? Pure. How do we know it's pure? There's only one type of atom in there? Okay, is it an element, compound, or both? It's an element. And then what phase would we say it's in? Gas. Any questions on A? What about B? Homogeneous, heterogeneous, or pure? Heterogeneous. We see this nice line of division right there. So it's heterogeneous. Is it elements, compounds, or both? Both. The top one is going to be which type? Compound. And the bottom one is our element. And what phases would you say these are in? Liquid and gas. So the top one would be gas and the bottom would be liquid. Why didn't we say it was a solid? It's not organized. It's not highly structured. Right? Yes, Lauren? Did that answer your question? Okay. All right, so I want you guys to look at your, let's look through H. Are there any questions through H? Look at them and ask those questions about any categories. Yes, Lauren?
G.
G. Okay, what would we say?
For
Hmm?
category 2, do we count that diatomic
It would, yes,
compound or
it would be an element. So G, I would call it an element because it is diatomic. Anybody else have any other questions on those? D? Okay, what do you want to know about D? First of all, let's look at category 1. Is it homo, hetero, or pure? Okay, let's look at category 2. Is it an element or a compound, or both? It's a compound. Okay, so how many compounds do we have in there? 1 or 2? 1. So is it? It's a pure substance. You could be a pure substance and water is a pure substance, but it's a compound. Okay? And then is it solid, liquid, or gas? Liquid. Why is it liquid? It's taking the shape of the bottom. It's not highly organized. They're looser out there. Okay? Good. Any other questions on those 8? Let's go to the next 8. All right. Questions about these?
okay. I think it's homogeneous, but
Okay. I would say K is homogeneous. Oops, hold on. So K, I would say, is homogeneous. Okay, there's not any nice place there where I can do a nice horizontal line of division in there. Okay, so I would call it homogeneous. And what did you say? Most of these are going to want to do the horizontal line. So if we can't draw a horizontal line, a nice horizontal line, not a vertical line, horizontal line, then I would probably call that homogeneous too. What about L? Heterogeneous. Okay, we've got a nice concave meniscus going on in there. What's the difference between I and M? The structure. So what would we call I? A liquid, while M is a solid. And what about O? A solid and a gas? Yes.
But that compound is polar when they try and make the close line to give it a structure.
What if it's not a polar? So a polar.
What is that?
It makes it look bent. It's not really bent. So, what compound would that be? What compound can be both a solid and a gas at the same time? Not water. CO2. And if you're a solid and a gas at the same time, that is called sublimation. And P. What about P? It's a solid. It's homogeneous, and it's elements, so this would be an alloy. Okay. Are there any questions on looking at those? Being able to identify what's going on in there? All right. Let's talk about separation of mixtures. How do we separate a mixture? So the first one we're looking at is decantation. So if you were to decant something, what type of mixture would it be? A homogeneous or a heterogeneous mixture? A heterogeneous. Okay. So heterogeneous mixtures, we can decant them. So this one, say we have sand and water here. And we are decanting off the water. Pouring off the water. What could be the drawbacks doing this? You can get some of one and the other. If you're like being sloppy about it, you might have to start all over again. Okay, so it might be a little time consuming if you've never done it before or you haven't perfected your technique. All right, any questions about decantation and what type of mixtures it would be? Okay, let's go on to filtration. So filtration, here we have actually taken the substance or the mixture and we are running it through a filter paper. So what type of mixture would this be? A hetero, homo, or both? Right. So if you had small, really, it depends on your filter paper and depends on your particle size. But for most of the time, this is going to be, for our purposes, a hetero mixture. You have a funnel. You put in the filter paper, and the filter paper is going to stop the larger particles from going through, and then the smaller particles will come out into your beaker. And you could, so you could do this with, say, water, or if you're making coffee in the morning, your coffee, you run your water through there and get your coffee out. Any questions over filtration? Evaporation. So what happens in evaporation? Can somebody tell me? So say in here, in this evaporating dish, we have salt water. So we have water in here, and we have sodium ions, and we have chlorine ions. So what's going to happen when we start evaporation? What do we need to do to start evaporation most of the times if you want to get it evaporated pretty fast? Heat it. So we're going to add heat. And what is going to be driven off as we add heat? It's going to drive off your water. Okay, and we're going to leave behind what? We're going to leave behind our salt. So what type of substances could be done with this? both. All right, if you wanted to filter your water, you could do some evaporation, but your water's going to leave, and so you're just going to be left with the salt. So you can't collect your water this way. Questions on evaporation? All right, let's talk about distillation. So distillation, what happens is you have your, whatever you're distilling is in here. It's in this flask, Florence flask. And what you're going to do is you're going to heat it up. And as you heat it up, you're going to start getting vapors. And the vapors are going to be drawn down into this tube. And what happens in this tube is we are bringing cold water in. The water is going around and around in this tube, and then the water comes out. And what happens to that vapor as we add cold water around it? The vapor is going to condense. And when it condenses, it's going to drip down into our flask. Yes?
Do you necessarily have to know that water, the water is the distilled substance?
Yes. You need to have something cooling it down.
Can't just have it.
No. I mean, it depends on where you're at, but you're going to have something to cool it down to get it back down into a liquid because it's going to be too hot. Okay, so what happens here is it increases your purity. All right, so you may have some meat, some sort of meat that you've been given, and you know how they tell you it's 95% fat or 80% fat. They can run a distillation on it and determine how much fat is actually in that meat. So distillation, you can take ethanols, alcohols, and distill it and increase the purity of the whatever you're collecting down here in this collection flask. If you take chemistry in college, you will do, or organic, you will do lots of distillations. And what types can be done with this? We can do both. Any questions on distillations? All right, paper chromatography. What this does is this has got to be a homogeneous solution. So we can take our pens or some ink, and what happens is we can put it in a solvent. So here is our solvent. And our solvent is going to go up the filter paper. And as it goes up the filter paper, it's going to take our mixture with it, and the mixture, depending on how much it likes the solvent, is going to travel up the filter paper. They had a question like this on the last AP exam. So depending on how far it travels, depends if we had, say, 3 different things here. If one traveled way up here and ended up right here, and then one ended up right here, and one ended up right here, we can determine which one, and this is a polar solvent, we can determine which sample was polar and which one is nonpolar based on how far it moved. Any questions on paper chromatography? Did we do this in did we do this in pre-AP?
I think so.
Not,
You did not. You came in the middle of the year, though, did you?
I came in after the first 9 months.
Yeah. And lastly, column chromatography. You can do this with DNA. You can separate DNA in column photography. This is based, it can be based on size, the size of the protein that you're looking for, or on the charge of your target strand.
Can you be based on both?
Huh? Can it be based on both? Ooh, I'm not sure if it can be based on both or not. I'll have to look into that. And this will be a homogeneous. The bigger it is, the slower it's going to travel. So we're going to have our big strands way up here, while our smaller strands of DNA will be down here towards the bottom, because it's going to travel faster. Any questions? Any questions on anything that I covered today? The types of mixtures, types of separation techniques, how to draw particle diagrams. Okay, so I am going to give you your homework.